All right. Hello, everyone. My name is Katarina Kosič Ficco. I work for the Virginia Department of Conservation and Recreation, the Division of Natural Heritage, as part of a small program called Karst program, as Karst protection specialist. And today I'm going to be talking about the secret life of caves. I know this has been a long day and this is the last presentation. However, I do hope you have coffee and popcorn ready, because we're going to descend into a very interesting branch of Karst science, and that is the subterranean biology. I'm going to be presenting the subterranean biology of Virginia. However, in order to truly appreciate importance of this science, we need to start at the beginning. And the beginning started here, in the land where people centuries ago learned how to live with karst, how to embrace these majestic karst features and learn from them. Where is this land? This land, it's located in a small little country in Europe called Slovenia, more specifically in a small area called Kras that was mentioned before by then Doctor. This is actually the area that attracted explorers and scientists for over 400 years now. You're probably wondering why this particular country, since it's such a small country. Maybe if I show you the map of caves, it's gonna help you envision why is that so. As you can see, Slovenia has a really high density of caves. In fact, it has approximately 14,000 caves recorded up till now. And basically, you could almost draw the borderline of the country if you would follow these caves. Additionally, karst and caves cover approximately 2/3 of the entire country. It helps it put even more in perspective if we realized that this country covers 1/5 of the land area of Virginia. However, it has approximately same amount of karst, which boils down to approximately 10,000 square miles of karst. When first scientists and explorers entered the caves of Slovenia, were impressed by large passages, extensive rivers that carved very deep canyons. More so, they probably just felt these canyons, since they didn't have such good lighting as we do have these days. And they usually just used a candle placed on their hats to explore these caves. Nevertheless, they found them intriguing enough to continue their exploration. Further on, they wanted to learn how these beautiful features were created. And that's how the science about karst was born. And this is why the word karst is coming from Slovenia, as already mentioned by then Doctor. During their exploration, they realized that there are actually animals that are able to survive in these harsh environments. And this is how the science of subterranean biology was born. One beauty of karst, but also what makes it very complicated, is that everything is connected. That's what you probably learn now through all these presentations. In fact, if we want to understand the biology of karst, we need to understand the hydrology, the geology, but most importantly, the structure of a karst system. That's why I wanted to once again repeat how a karst system is structured. Karst system, it's primarily structured of 2 zones. The first one is the phreatic zone, or so-called saturated zone, where the voids are fully filled with water constantly. The second zone is so-called vadose zone, or unsaturated zone, where the voids can be filled with air and water, depending on the water conditions outside and in the cave. Then we can split a karst system into two subzones. The first one is the epikarst, which constitutes the uppermost part of the vadose zone, and it's primarily structured out of small fissures and voids that are not accessible to a human being. The second one is the epiphreatic zone. This is the area that regularly floods in the cave when we have high water levels, but drains during low water levels. Now, when we understand all these zones, we can better understand the biology and its importance. One of the most important and famous subterranean species is definitely the Proteus, or better known as the human fish. This blind salamander primarily lives in the phreatic zone and epiphreatic zones of a karst system, and it was first described in distant 1689. And this blind salamander, it's a great example how complex karst is, as even after 300 years of studying it, we are still learning from it. And similarly goes for all branches of karst science, hydrology, geology. Every day we learn something new. Of course, this is not the only subterranean species in Slovenia. In fact, there are over 300 cave-adapted species currently known in Slovenia. Let me emphasize that that's a very approximate number, as the scientists are still building a full list, and to complicate things, they're discovering new species on a yearly basis. A lot of people is surprised, why are we so interested in these little bugs? Well, first of all, these little bugs were able to survive millions of years in these dark environments with very limited energy input. Additionally, they adapted their bodies in order to survive in these environments. In addition to that, these little critters can serve as bioidentificators, showing us the ecological status of subterranean habitats. Now, why is that important? That it's particularly important for states such as Slovenia and particularly rural Virginia, where people commonly rely on karst groundwater as the primary source of potable water, meaning drinkable water. If we understand the subterranean habitats of aquatic species in these aquifers that are used as the source of potable water, we can understand the healthiness of these groundwater systems. Following, we can monitor these species and detect if anything changes. If these communities deteriorate, then we can assume that the water quality deteriorated as well. In addition to that, these critters can serve as tracing tools. For example, we have epikarstic communities. These communities enter the cave through the epikarst, hence through these fissures that we cannot access. If we detect where these creatures enter the subterranean world, we can also assume that the water enters the subterranean world at the same area. Hence, evaluating in case of any potential surface contamination or spillage, where that contamination could penetrate the subterranean world. In addition to that, we can use cave species to determine the subterranean interconnectivities. Of course, the science about karst didn't stop in Slovenia. In fact, it quickly spread over the entire Dinaric karst. Dinaric karst lies northeast of Adriatic Sea and stretches over the so-called Dinarites, a mountain chain from which it got the name. It also stretches over several countries, and it constitutes continuous carbonate rock. What does that mean? That means that we're talking about one single chunk of limestone, if I may call it so, that stretches over 50,000 square miles. The word continuous, it's very important. As we will learn later, in Virginia, limestone is quite different. In addition to those 300 species found in Slovenia, several more were found in the Dinaric Karst, in the rest of the Dinaric Karst, making Dinaric Karst the world hotspot for subterranean biodiversity. It is not all roses, though. There is a cost to this fame. Dinaric Karst is attracting explorers, scientists, tourists, but also collectors. You can imagine that throughout the history of subterranean biology, several species got interesting names, such as, for example, Anophthalmus hitleri. Particularly, such species are very interesting to collectors, meaning that Slovenia in particular now attracts cave poachers. How do cave poachers act? They usually find really easily accessible caves with large entrances and horizontal character. They enter these caves. They place illegal baiting stations in the caves and then return to collect only the species they're interested in to sell it on various collectors' gatherings. Biologists in Slovenia are therefore trying really hard to inform people about this illegal activity and also properly mark their baiting stations when they are surveying for subterranean biology. So what is the main difference between these two traps? Well, the scientists usually enter the cave, place a baiting station, and return in a determined amount of time, when they collect all the species that got caught in this trap, and then they remove the trap. In order for people to understand that that's a scientifically placed baiting station, they also properly label the station. The poachers usually set the baiting station and leave it there when they leave, so that it basically becomes an indefinite death trap for all the species that live in a cave. You can imagine that after such an extensive history of research of karst, Slovenia has pretty thorough karst protection legislation. And it is indeed so. The caves in Slovenia are all governmentally owned and hence very strictly protected with a Cave Protection Act. In addition to that, Slovenia has a very thorough karst groundwater protection legislation developed. Because of that, also with these poaching activities, the National Environmental Agency got involved and developed a brochure in which it explains that such activity is taking place. It's educating people how to behave when they see such traps. It's also educating people on the importance of the subterranean biology and the importance of karst itself. Now, if we leave Europe and fly over the ocean and land in the karst of Virginia. Karst of Virginia can be primarily split in four main regions. The Great Valley region, which was previously described by then Doctor, that encompasses primarily the Shenandoah Valley, the Highland region, the New River Valley region, and the Mountain Empire region. If we look at the Karst of Virginia, it stretches over the Appalachian Mountains, and you can see that it's structured from different types of limestones, ranging from Mississippian down to Cambrian ages. Virginian karst covers similar area than Slovenian does, approximately 10,000 square miles. The main difference is that Virginian karst constitutes non-continuous limestones. Basically, you can envision small islands of soluble rock surrounded by an ocean of non-soluble geology. This limits the development of cave. Nevertheless, Virginia still has approximately 3,000 caves recorded. Now you can see that the number is still much smaller than the one in Slovenia. Well, one of the reasons is obviously the stratification of the limestone. The other is that exploration and science of karst, it's much younger in Virginia. In fact, it's approximately 100 years younger than the one in Slovenia. Another major difference between these two karsts is the age of the limestones. The limestones in Europe are approximately 50 to 70 million years old, while the ones in Virginia are over 300 million years old. As it was previously explained by Dan Doctor, we should not exchange the years of limestones with the age of karst. In fact, currently, the existing caves in Virginia are approximately 5 million years old. So why such a big difference? Well, the Virginian karst, in addition that it's very old, also lies on one of the oldest mountain chains in the world, meaning that these mountain chains, the Appalachian Mountains, changed significantly through the history. Once again, for those who want to learn better about how they developed and changed, I suggest you relook Dan Doctor's presentation. But over these hundreds of millions of years, these mountains weathered away, got eroded, and with them, probably also the old karst. Additionally, these several hundred of millions of years took care that the landscape got covered by very thick soil covers. So why do we believe that karst was potentially older than we can currently date the caves in Virginia? Well, interestingly enough, as you're gonna learn later in the presentation, once again, it's because of a very small little critter and subterranean biology. Now you can see that the age of the mountains and the limestones, and also the young age on the opposite part of karst science, limits our understanding of Virginian karst, or at least can limit it. However, there are definitely things that we definitely know for sure. One of these such information is that the stratification of Virginian karst doesn't only limit the development of caves, it also limits the migration of subterranean species. In order to better understand this, I used delineated ranges for the Pseudonotalamus species, which is the only species of a cave beetle that can be found in Virginia. Already on this map, you can see that the ranges pretty much follow the strata of the limestone. If we zoom in for better understanding and look at the range of Pseudonotalamus potomaca, as you can see, this beetle only lives and follows the Devonian limestone. And not only that, it can only be found in one strata of that specific limestone. In fact, we never found it in surrounding Devonian limestones that are not connected with the one where the Pseudothalamus potomaca lives. Using biology, therefore, we learned that indeed stratification limits the range of species, of subterranean species and of the caves, that the cave fauna can be used to identify the connectivity of cave systems. In fact, more often than not, we, for example, only find certain species in one drainage and in one specific geology. But as you will learn later, as I already mentioned, it also can help us identify the age of karst. How do we perform biology inventories in Virginia? For difference from Slovenia, we don't usually set baiting station, mainly due to lack of resources and time. That's why we usually perform biology inventory in situ, meaning that we enter a cave and we try to sample most common habitats in order to find and identify the majority of species living in a cave. We are actually quite successful with this approach. We have various aquatic amphipod species and different aquatic isopod genera. We have various terrestrial species, such as cave spiders, cave millipedes, cave beetles, and pseudoscorpions. Sometimes in situ inventories prove to be actually better, because if we're lucky enough, we enter the cave when pseudoscorpions are carrying eggs. I can assure you that's a very rare sight, and it was super awesome to see it. We also monitor bats, about which you learned in the previous presentation. We have several different species of bats. And we encounter also quite common species, such as cave salamanders, which are not blind in Virginia. Up till now, we have approximately 200 documented limited invertebrate species. And among them, 150 are globally rare, meaning that they can only be found in one or handful of caves worldwide, but most commonly only in Virginia. Virginia as well has its biodiversity, subterranean biodiversity hotspots. You can see that they primarily correlate with the cave density, which makes sense since we can only sample what we can enter. That is what makes us wonder how much more species we could find if we could, for example, find more caves in Shenandoah Valley. There is, however, one exception, and that is the Southwest Virginia. As you can see, despite the cave density might not be so high down there, the biodiversity is extremely high, making Southwest Virginia actually a world hotspot for subterranean biodiversity. Why is that? Well, once again, that is primarily due to the stratification. In fact, particularly in Southwest Virginia, we find species that only live in one spring or in one cave. And then we can sample adjacent caves for the same species, and we will never find it. A great example are the isopods in the genus Lursius. These little isopods are particularly interesting because we can actually see the differences between them with our bare eyes. So we don't actually need to be the taxonomists. As you can see, we have Lursius isopods that are completely cave adapted and ones that are actually more surface species, in fact, more found in springs. just looking at these 5 species, they are new species that were recently found by sampling additional springs and caves. And particularly with this genus, we actually find new species almost on a trip-to-trip basis, which is quite impressive. And well, I can say that basically this genus is definitely leading in the biodiversity. Virginia has its celebrities. One of them is the Madison Cave Isopod, and the other one is a fluffier Virginia big-eared bat. These 2 species are both endangered and listed on the federal and state levels. Madison Cave Isopod, it's particularly interesting. First of all, it only lives in the phreatic zone of limestone aquifers. It's only known from 11 caves and 7 wells in the world. They are all located in Shenandoah Valley and in a small section of West Virginia. But what is most interesting about this particular species is that it's believed its ancestors are actually marine ancestors, meaning that this species got introduced in the subterranean world of Virginia in Cretaceous age, meaning that it's probably over 70 million years ago that this particular species enter the underground world of Virginia. And that is the species that makes us believe Karst can be older in Virginia if we could actually sample and find it. As I already mentioned, it's also listed as endangered species. Then we have the big-eared bat, which caused a lot of concern when the white nose syndrome impacted Virginian bats. You learn more about the white nose syndrome before. It's a fungus that significantly depleted bat populations in the eastern USA. The interesting part is that this particular bat, does actually not appear to be affected by the white nose syndrome, which is a relief. It is, however, very significantly affected by human interference. As you can see, it has very big ears, and I can assure you that even if you're trying to be quiet as a mouse when you enter a cave, this fellow is going to immediately pop the ear up and let you know that he is looking at you. You can only imagine that how impactful can then be if we enter a cave very loudly and wake them up, particularly when they are hibernating. Virginia has its threats. They're not so commercially oriented as the ones in Slovenia. However, and they're usually more or less connected with poor human management. A great example are so-called improved sinkholes. Improved sinkholes are one type of stormwater management allowed in Virginia. However, if you look at the legislation, there is no specific definition how an improved sinkhole should look like. Meaning that more often than not, an improved sinkhole boils down to a stormwater culvert that you can see here on the left, redirecting the runoff from an interstate highway into a sinkhole. This runoff then sinks underground, and I guess we could say we can forget about it, right? We can't see it anymore. Well, we actually can see it. This particular runoff that disappears in this particular sinkhole flows in a cave that serves as a summer colony for another endangered bat species, the gray bats. Additionally, that cave actually has a stream, obviously, that has several aquatic species in this stream. If we look at how that stream looks like after a major rain event, you can see foam floating on the surface of the water. And what you cannot detect is the reeking of fumes that are evaporating from the petroleum that floats on the water surface. Today you learned through different presentations how these streams in the caves are actually connected to sometimes to potable water sources, to wells that are used for drinking water supply. That is why this is an additional concern, as it's not only impacting the species in the cave, but it might be impacting someone's water supply. Nevertheless, we do try to protect as much as we can. So how do we protect? Virginia has a Virginia Cave Protection Act that to some extent protects the caves. It also establishes the Virginia Cave Board, which is the advisory body about caves and karst in Virginia. We also perform comprehensive biology inventories so that we learn about these systems and how to protect them. We perform groundwater monitoring and monitorings of different species. For example, we monitor bats by bat counts, song meters, and different data loggers that are recording bat activity. We perform tracer tests in order to establish groundwater connections, but also groundwater and surface water connections. We try to educate and inform people about the importance of karst resources. We delineate conservation sites. Anytime we find a new species or a species that is globally rare, or we have a significant cave that is defined as such by Virginia Speleological Survey, we delineate a conservation site. These conservation sites are not legally binding. However, they do help us present to various stakeholders the vulnerability of a specific area. DCR owns several natural area preserves, among which several have karst resources, such as this pretty impressive spring, which is almost a tunnel. We cooperate with federal and state agencies and other stakeholders, including university and various private stakeholders. Most importantly, we cooperate with landowners. With cooperation with landowners, we can, first of all, educate them about the importance of karst, but even most importantly, they can educate us about their karst. It's very often that we're going to find new caves and new springs because the landowners point them out to us, and we would never find them otherwise, as there is a lot of walking when you're searching for caves and springs in Virginia, primarily because they are mostly covered. We cooperate with local cavers that often turn out into volunteers. Thank you so much for that to everyone. And most importantly, we cooperate with nonprofit organizations without which sometimes we might even cease to exist. On that note, I would really like to thank the Cave Conservancy of the Virginias, without which we would not be able to perform such thorough research and maybe wouldn't exist. And also to the Virginia Speleological Survey, as they are the ones that manage cave data in Virginia, and they do it so that the privacy of cave locations is fully assured, but at the same time, karst is properly evaluated and hence also managed to the best extent. I would also like to thank everyone that were willing to share their photos and awesome videos with me, since that means that the presentation was a little bit more bearable. And now I'm ready for questions, while you can see bats fly around.
Wow, thank you, Katarina. That was fabulous.
Thank you.
Who has questions? Let's see. Danny in the chat has a question. Oh, he's got a question that I can't pronounce.
Let me read it. But I do need to get out of the video.
Okay.
Just give me a second. Okay, I'm gonna.
You can stop sharing.
Stop sharing.
Yeah.
Okay. Oh, so, oh yeah. So, yeah, I forgot to mention, I'm originally from Slovenia, from that beautiful land of Kras. I have a PhD in karstology. That's how we called karst science in Slovenia. I actually shared the link to my PhD in this event today. And I ended in USA because I got a scholarship to perform research work in Arkansas with Matt Covington, who is an amazing karst scientist and has an amazing karst research group. And well, then I went on an expedition and met my husband, who is also an eager caver, and ended in Virginia. And was lucky enough that Will Orendorff, the director of Karst program, wanted to hire me.
And the Commonwealth of Virginia is lucky to have you both.
Thank you.
So Danny has this question about.
Oh, Danny.
Yeah.
Oh yeah, no, I did not have the chance to observe it in their habitat. Those are all photos from my colleagues in Slovenia that are biologists at the University of Biology in Slovenia. The only specimens I was able to observe were terrestrial isopods and Proteus, of course. It's quite common. And cave beetles. I go to Slovenia very rarely. Once a year. And when I go, I do help sometimes with subterranean biology, but often I'm more focused on exploration. And at that point, it's hard to observe biology since you're looking at the potential lead.
And Tom asks, what will climate change do to the cave ecosystems with more droughts and floods?
That's an interesting question. I guess we shall see. I mean, one problem with estimating what's going to happen is the lack of background research. So in order to truly be able to assess what's going to happen, we would have to monitor different cave systems and karsts for, I don't know, 50 or 100 years, right? And usually that's not the case. I mean, even if we are learning about karst and even if we're studying it, we usually don't have monitoring stations in a cave for such a long period of time. We are definitely observing basically greater flooding events in caves. I know we cannot say it's due to the climate change, but definitely recently when the winters were they were warmer, we did have a lot of events where the caves flooded, and that is definitely impacting the cave systems. It's also because we don't have such long winters and snow anymore, the water, basically aquifers, get depleted because the snow kind of recharges aquifers slowly. And it's keeping them recharged. While if we just have major rain events, usually the water just flushes through the system and disappears. So we have prolonged droughts in the caves because of that. So yeah, I don't have an exact answer to that, but it's definitely impacting it.
Okay, and Sarah Fleetwood asks, do biologists study how the structure of cave-adapted insects varies from those found on the surface? For example, the concentration and arrangement of chitin in the exoskeleton.
Yeah, the great example is definitely Lursius, and if you look at some publications of Jerry Lewis, he definitely describes different Lursius species and basically their differences, right? You could see already just observing just with bare eyes, how they differentiate between the color, in the eye structure, and that's of course even more so if you are a taxonomist. So they definitely are monitoring that and studying that, and there is a lot of publications out there to explain these elements.
Okay, anybody else have questions? No? Okay, well then, we are finished.
Yay!
And I am going to, let's see.
There is one more question. What is the food for the critters? When we bite, we set bite stations, we usually, it depends. In Slovenia, they use rotten meat, raw rotten chicken usually. We tried with very old stinky cheese. Sometimes it works, sometimes it doesn't. We also heard that peanut butter works. We need to try that, but they had good success for trapping beetles with peanut butter. So I guess cave beetles like that. The other species, it depends. Some are eating, some are carnivores, and some are just eating the algae and different organics on the surface. The fourth area of Karst, Virginia was the Mountain Empire. These regions are mainly, we basically just split these regions. Let me share the screen again, just to ease our explanation of Karst. It's a very rough delineation of the regions. Oh, sorry. Now we're going to be flying again. Sorry for that. Here you go. These are the primary 4 regions of Karst in Virginia. Okay. Sorry, Meredith. I just figured I should answer them.
No, that was great. Okay, last call for questions. All right. Thank you so much, Katarina, and thank you everybody else, all the other speakers, a lot of whom are still hanging out with us. And thanks to everybody who showed up today. And we're ending a little bit early, so you've got some extra time now, but thanks for coming. All of these presentations will be posted online at some point. So thanks.
I would also like to thank you, the Cave Board, and everyone that were involved in organization of this event. It was a very beautiful event and important for Karst in the USA. Yes,
Janet Tinkham and Carol Tiedemann and every speaker we had. You guys made it. Thanks.